Okay, 2.1. Identify the hypothesis and conclusion. All right, so if we just blow this up here a little bit, and let's get rid of that. All I want you to do right now, instead of writing it down, you could, actually I want you to write it down. And you have to identify what the hypothesis and conclusion are. Hypothesis is the if part, so on number 1, there's your hypothesis. And your conclusion is the last part. So the hypothesis, a polygon, is a pentagon. And the conclusion has 5 sides. All right, number 3, you run, that's your hypothesis. You're fast, that's the conclusion. It doesn't mean that it's true, it's valid. It's a valid statement. Doesn't mean that it's true. All right, let's move on. And rewrite the conditional statement in the if-then form. Okay, so I'm going to go ahead and blow this up again and just kind of write above and below each thing. Let's go ahead and say number 5. It says 9x plus 5 equals 23 because x equals 2. All right, so you sit there and you say, if x equals 2, then 9x plus 5 equals 23. You also could have said, if 9x plus 5 equals 23, then x equals 2, which is what most students typically do. But either one of those I would take when it's talking about algebra. I really think the 9x plus 5 equals 23, and then x equals 2 is the better way to say it. Now let's go down to number 7. When a glacier melts, the sea level rises. All right, so you could say, if a glacier melts, then the sea level rises. Okay? And then number 9, only people who are registered are allowed to vote. If you are registered, then you can vote. Or then you are allowed to vote. Okay, next one. All right, rewrite the negation of this statement. All right, so the negation, number 11. The sky is blue. All right, the sky is not blue. That's the negation. Number 13, the ball is not pink. The negation would be, the ball is pink. That's what negation means. Next. So rewrite the conditional statement, the converse, the inverse, and contrapositive. All right, so you don't worry about the P's and Q's. That's when you get to philosophy and stuff later on in college and stuff. Don't worry about that stuff. Then decide whether each statement is true or false. Okay. So right now, I just want to know, I want you to rewrite all of this stuff. The conditional, then the converse, the inverse, and the contrapositive. All right, so just like what we discussed in class, the conditional first, let P be 2 angles are supplementary, and let Q be the measures of the angles sum to 180. So if 2 angles are supplementary, then the measures of the angles sum, then the measure of the sums, then the measures of the angles are added to equal 180. Okay, that's your conditional statement. Now, let's turn this around. The converse. So the converse, these two go together. You have your statement, and then you switch the if and the then, the hypothesis and the conclusion, just like we talked about in class. If 2 angles are added together, or if 2 angles added together equal 180, then they are supplementary. Okay, and then the next two things go together. So I'll do this one in blue. The inverse, and then also the contrapositive here. So the inverse is taking the conditional statement and rewriting it with the negation of the conditional statement. So you literally just take your conditional statement and negate the hypothesis and the conclusion. If two angles are not supplementary, I'll just abbreviate, then let's do their sum is not equal to 180. All right, so if they're not supplementary, then their sum's not 180. All right, so I'm abbreviating here. And then you do the contrapositive, and the thing on this is these two go together. So you literally just pick up the conditional and the converse and rewrite them for the last two, the inverse and the contrapositive, but negate everything. So now you take the contrapositive. So if the sum of two angles does not equal 180, then they are not supplementary. All right, so the contrapositive just takes the inverse and switches it. Just like the converse, what it did is it took the hypothesis and the conclusion and switched it from the conditional. All right, next. Keep going, number 17 here. So on number 17, let's see if we can do this right here. So we're going to do, you got to do this 4 times for each of these. So the first one is the actual conditional. All right. So if you do your math homework, if you do homework, let's just do this. All right. Then you will be, you will do well on the test. Then you do well. All right, we'll just shorten it for the moment. I want you to write it out. If you do homework, then you'll do well. And then the inverse is the switch of that. If you do well on the test, then you do your math homework. Okay, and then we go to, excuse me, that was the converse, not the inverse. Sorry, converse. Now we do the inverse. And the inverse is taking each of these, and we just rewrite these. I'm just going to rewrite them just like they are, and I'll show you how you do this. So if I take the conditional, I'll write it. Now just give me a second. If you do your math homework, oops, then you do well. Okay. So, and then I'm going to write the contrapositive here, meaning I'm taking the converse. If you do well, then you do homework. All right, so watch what I do here. So notice that these two statements and these two statements are identical. Now, all you have to do with the inverse and the contrapositive is negate everything. If you don't do your homework, then you don't, don't, apostrophe in the right place there, don't do well. If you don't do well, then you don't do your homework. That's all you have to do when you do this. The conditional statement's easy. You just write your if-then statement. And then for the converse, switch the order of the hypothesis and conclusion, and then rewrite both of those exactly the way they are as an inverse and a contrapositive, but then rewrite it so you negate everything. All right, let's do number 19. All right, number 19. Let's, we'll write the whole thing here. If it does not snow. Now, be careful of the negative there. If it does not snow, then I will run outside. Okay, now that's the conditional. So the converse is change everything. If I run outside, then it doesn't snow. Oops. Okay, so let's go ahead and rewrite both of those statements. If it doesn't snow, then I will run outside. Okay, and then write the conditional there. Or excuse me, the converse. That's the converse. So if I run outside, then it doesn't snow. All right, they're identical. Now we negate them. So this will be the inverse, and this will be the contrapositive. All right, so how am I going to change this? If it doesn't snow, we're going to scratch that. I forgot the end there. And say if it does snow, then I won't run outside. Contrapositive, if I don't run outside, then it snows. Then it does snow. Okay, you can say that. Then it does snow. So you got to negate everything. So you're really only writing 2 sentences here. All right, then 21, let's redo it again. All right, 21, the conditional. If, we'll write it the way I want you to write it. If 3x minus 7 equals 20, then x equals 9. Doesn't matter if it's true or false, even though the instructions say write true or false, okay? You can solve it, add 7, that's 27, divided by 3, x is 9. So that's a true statement. All right, now, if we go to the converse, switch it all. If x equals 9, then 3x minus 7 must be 20. That's a true statement too. All right, there's only one solution for that problem. All right, now let's rewrite everything again. If 3x minus 7 equals 20, then x equals 9. And then if x equals 9, then 3x minus 7 equals 20. All right, so the inverse, we negate everything. If 3x minus 7 doesn't equal 20, then x doesn't equal 9. If x, and then your contrapositive here, okay, if x doesn't equal 9, then 3x minus 7 doesn't equal 20. All right, next slide. Decide whether the statement about the diagram is true. Explain your answer using the definitions you've learned. All right, so listen to your instructions. I mentioned this in class. Do not assume anything unless you have proof of what it is you're saying. Just because something looks like it is doesn't mean it is. You have to, in geometry, this is logic class, you must defend with facts what it is you're saying, not because you think something is. So on number 23, the measure of angle ABC is 90. So is that true? And the answer is yes. And the reason I know that is because of this symbol right here. That means 90 degrees. So I know this is true. Just for practice, number 24, does angle S equal angle T? Is it congruent to angle T? And you would say, yes, it is. That is true. Now, here's why it's true. Not just because it says 43. Because this is what I've been trying to get you to be seeing, and real soon you're going to have to say this. Because what you have is the measure of angle S is equal to the measure of angle T. And if you have equality, then you also have congruence, and vice versa. So those two have to go hand in hand. So just remember that for what's coming. Next slide. 25. The measure of angle 2 plus the measure of angle 3. So addition postulate, angle addition postulate equals 180 degrees. That is a true statement. Why? Because we know that MNP is a straight line. And a straight line is supplementary, or it's 180 degrees. That means angle 2 and angle 3 are a linear pair, And by definition, a linear pair adds up to 180. And you're right at that point. So let's go on. All right, so just like we discussed in class for biconditional, this is used on almost every test we've ever given. The midpoint of a segment is the point that divides the segment into two congruent segments. So you would say a point divides a segment into, sorry, capital A there, into two congruent segments. And then here it is. If and only if. That's your biconditional. If and only if it is the midpoint. All right? You could also say, if a point is a point is a midpoint if and only if it divides it into two congruent segments. So you could change the order of that. So let's look at number 29, shall we? 29, adjacent angles are two angles that share a common vertex and side, but have no common interior points. Okay? So you could say, adjacent angles are two angles, and if and only if. So there's a symbol you can use instead of writing that out. If and only if they share a common side, common vertex and side, but have no common interior angles. Next, 31. If a polygon has three sides, then it is a triangle. If a polygon is a triangle, then it has three sides. All right, so rewrite the statements as a biconditional statement. So, a polygon has three sides if and only if it is a triangle. Now you can say a polygon is a triangle if and only if it has three sides. All right, so a polygon has three sides if and only if it is a triangle. Good enough. 33. I'm just wanting to make sure you know when to use if and only if. You could change the order of some things. Right now we're focusing on that. If an angle is a right angle, then it measures 90 degrees. If an angle measures 90 degrees, then it is a right angle. All right, so an angle is a right angle. Right angle, sorry. All right, right angle, if and only if it measures, or it has a measure of 90 degrees. All right, next. All right, last two problems here, review. Let's go make sure we can do this, 73. Try to do this on your own. As always, try to do them all on your own. So we can distribute this way, z squared plus 8z minus z, and then minus 8. But don't forget to look for common terms, so that's plus 7z minus 8. All right, and then 75. We're going to put like terms together. This is an addition problem. Number 73 was multiplication. So make sure you know which one you're doing. So we're adding here. And notice on 74, that's subtraction. If you ever have a subtraction, which you will, make sure you distribute the minus sign through. So that would make that a plus 2 when you're adding things together. All right, 75. Negative 4n cubed. Well, they don't have a 4n cubed in the second part, so it doesn't disappear, but it doesn't go away. Okay? It doesn't get added with anything. So now I have a n squared and a 6n squared. So a minus 1n squared and a positive 6n squared, that gives me a positive 5n squared. Okay. And now we have a 5n all by itself. Notice I'm including the operation in front. A positive 5n, it doesn't go with anything else, so it doesn't disappear. And we also now have a plus 8 and a minus 9. So that would be a minus 1. Hopefully you got that right, and that's your homework.